Hi guys, I know I said that the last video was the last video, but unfortunately it ran a little bit long. So this is again Unit 7, Day 3, and we're on video number 5. So I filled in some of the work here for this example just because it's very similar, and I think that most of this will be okay for you. I just want to talk through some of the places that I really want to draw a focus to. So we're going to sketch this function f at x by finding the horizontal and vertical asymptotes. So I think vertical asymptote's pretty straightforward. We're going to factor the denominator and set it equal to 0 and find where those restrictions are. So my vertical asymptotes are at -1 and +1. So in this case, I'm going to do a different kind of table showing how you could use test values instead of sign analysis to figure out whether this function is approaching negative or positive infinity at these points, or around these points. So here I might do a test value of -1.01 to find something on the left, and -0.99 to find something right on the right of the -1, and then 0.99 and 1.01. Again, be careful here thinking about left and right of negative numbers on a number line. I know that sounds obvious, but I have seen people make mistakes with that. So if I take those numbers, and you'll have to take -1.01, sub that value in to f at x, you will end up getting a large negative number. So this is going to be approaching negative infinity. I think it ends up being like -300 and something. If you take -0.99, you will end up getting a large positive number. So it's here approaching positive infinity. If you take +0.99, we will end up getting a value approaching positive infinity. So on the left side of that x equals +1 asymptote, it'll be going up to positive infinity. And here we end up approaching negative infinity. So I'm going to do really what the new thing is in this course compared to in advanced functions when you are looking at vertical asymptotes, is to summarize this with proper limit notation. So I'm just going to write out, like formally with limits, the limit as x approaches -1 from the left of my function f at x equals negative infinity. So I just want to see a limit statement for each side of the vertical asymptotes and for the horizontal asymptotes at negative and positive infinity. So as x approaches -1 from the right of f at x, we go towards positive infinity, and the other two, the limit as x approaches +1 from the left of f at x is infinity, and the limit as x approaches +1 from the right, all these plus and minus signs in there, is negative infinity. So that's how you would summarize your answer, summarize your work around those vertical asymptotes. Now the horizontal asymptotes, I'm again taking the limit as x approaches infinity of my function. I'm dividing all of the terms by x squared, or multiplying everything by 1 over x squared, which will simplify to 1 plus 2 over x minus 5 over x squared over 1 minus 1 over x squared. Of course, as x goes to infinity, anything with an x in the denominator will go to 0, a constant number over a denominator of x. So when I evaluate, I get 1 plus 0 minus 0 over 1 minus 0, and my horizontal asymptote is 1. You guys would have known that even from the advanced functions course, because you would have looked at the coefficient of the largest exponent on the top and bottom. Okay. Here, we're going to do test values and testing +1,000 and -1,000 to see, does this go really off towards 1 from above or from below. So if I'm doing +1,000, I end up with about 1.002. And if I'm doing -1,000, I end up at about 0.998. So this tells me as I go to positive infinity, I'll be above the horizontal asymptote. And as I go to negative infinity, I'll be below the horizontal asymptote. And I'm going to summarize that down here as well with my limit notation. So the limit as x approaches infinity of f at x equals 1 from above. So that plus means above the 1, above the horizontal asymptote. And the limit as x approaches negative infinity of my function f at x equals 1 from below. As I'm going to negative infinity, it's slightly below that horizontal asymptote. So we're going to take all of this information and summarize it together and put it all into a graph. So lost my ruler, but here we go. Setting up your graph, you do want to make sure that you draw in all of your asymptotes using dotted lines. Lower that a little bit. If you're doing a scale of 1 square is 1 unit, I don't need you to show me that. You don't need to label your scale if it's just 1. So I'm going to put in my vertical asymptotes at -1 and +1. And my horizontal asymptote at 1. Okay, so when I'm going to graph this, what I'm really going to be looking at is the summary of this limit notation. So I know around the -1 asymptote, on the left, it's going towards negative infinity, and from the right, it goes towards positive infinity. So I'm going to look at this asymptote here, and I'll draw my function in going towards negative infinity and going towards positive infinity there. Okay, for the x equals +1 asymptote, it's going towards positive infinity on one side and negative on the other. So positive infinity there and negative from the right. Okay, we can kind of look at the last one. If we look at the function here, it says it's going towards the horizontal asymptote from above. So I'm going to, again, kind of sketch that out from above, and it's going towards at negative infinity from below. So here, this section and this section seem to make pretty good sense, right? We're going to have some kind of curve there, and I think that I actually drew this middle piece way too low because it's got a y-intercept of 5, but we're gonna not worry about intercepts quite yet. So that seems to kind of connect. The problem is here, this is not what we probably would have expected here, right? If we just knew about the vertical asymptote, I bet we all would have said, it probably just goes up towards the horizontal asymptote, similar to this one. But we tested this and we know that it's approaching from above. So this must actually cross the horizontal asymptote and come back down somehow. You could figure out where that happens by subbing in back to your original function, y equals 1, and solving that equation. So if you wanted to double check, we could put in y equals 1 and cross multiply. I'm just trying to kind of look here. I think it crosses at 3, but don't quote me on that because I'm kind of solving it in my head. You guys can throw this into Desmos if you want to get some more accurate picture of it, but it must kind of go up and then loop back down towards that asymptote. So this is just describing asymptote behavior. We could get some more interesting stuff if we found the zeros, for instance, by using the quadratic formula on the numerator, found the y-intercept, which I think is actually up there, but I'm a little bit off my scale. But graphing it just with the behavior around the asymptotes, we're actually able to get a pretty accurate graph. In the next lessons, we're going to be looking at how we can kind of combine together the local max min. So for instance, there would be a minimum here, there would be a maximum there that we would be able to find, and the intervals of increase and decrease to get much more accurate graphs, as well as some of the stuff that we've done in grade 11 and advanced functions, like those zeros and the y-intercepts. So other stuff as well can help us to graph more accurately.